Okay, guys. Good afternoon, everyone. I hope you're doing great. The thing is, those who want to follow the book, we start from page 56 quickly. We spent 12, 15 minutes to review quickly what we discussed yesterday and the important points, and get prepared for the major part of today's lecture, which is going to be IMDb dataset and the prerequisites that we need before starting that. So we bring everything to the point that you will be ready to understand what we have inside that model. So we said there are three most common use cases that we are going to consider in the current chapter. One of them is binary classification, and the other one is multi-class classification, and the last one is scalar regression. And there are tons of examples for that. For instance, for binary classification, one of the most common use cases is sentiment analysis, or saying if a text or a review is positive or not positive, right? And for multi-class classification, imagine that you want to distinguish different pictures of animals and you want to classify them into different categories. It could be one of them. And the scalar regression, expecting the price of, for instance, house, stock, or anything, and the prediction that could be close to real numbers. So it says that all of these examples, they are based on vector data, but normally we do not use very much deep learning for just non-perceptual or structured data. We use them mostly for non-perceptual. The other thing, it says that the anatomy of, or physical structure of a neural network consists of these components. One of them, we can say layers that they form our network, our model. The other one are the inputs and the corresponding targets or outputs. The loss function is responsible to calculate how off we are from the real answer, and it's going to bring you back a feedback signal that you can correct yourself using optimizer. And you remember that based on the derivative functions and gradient, we can just adjust our minimum to lower down the loss. This is a familiar graph that everyone knows that. Like Nicholas, you remember we said that this is not the best picture because optimizer should change all the weights and biases. So in the recent version of the book, it just corrected that part, but it didn't show anything about the biases. In the text of the book, you see that it says we change weights and biases, but in the picture, it didn't show anything about that. As several times we insisted and we've talked about, the most important and fundamental building block of deep learning, which is layer. And we said that some layers are stateless and some layers are stateful. The stateless means that, imagine that I give you a picture of a cat and I show you, okay, this is a picture of a cat. So you're gonna just wrongly predict it. Machine learning, deep learning is going to predict it wrongly. But next time, for the next picture after doing those backpropagation and optimization, we expect that it is getting better and it shows a better result because it is going to memorize and remember the values of the current network. But if we do not remember that, it's going to be stateless. So the question for you is, what we have in deep learning, is it stateful or stateless? Pardon me? It's going to be stateful. Why? Because it stores the values. True. True. Where do we store the knowledge? The knowledge stores in weights and biases, right? Look at this one. It says that the layers weight one or several tensors learned with stochastic gradient descent, which together contains the network's knowledge. So the knowledge of the network exists in weights and biases. Then it talks about the simple vector data. And the next part, it says that you can think of layers that we have as Lego bricks of the deep learning, that they're going to stack up on top of each other. And do we need to, that's another question, do we need to tell what is the input value for each layer? Do we need to? So what's going to happen? Look at this. Here it says that layer is equal to layers.dense 32 input shape. So those who finished assignment 1 and watched the recorded session, watched the video that I suggested, they know that the gentleman didn't consider any input, right? In that case, automatically it's going to find the output of the previous layer, which is going to be the input of current layer. The other thing is, it says that when using Keras, you don't have to worry about compatibility because the layers you add to your model are dynamically built to match the shape of the incoming layer. So this is what I just talked about. And look at this one. In this line, first question, Nicholas, do we need to have any input shape or not? Pardon me? Lovely. Automatically. Excellent. Excellent. And if I want to assign, what should I say? Just if I want to assign. Anybody can just step in. Good job, Nicholas. If I want to assign input value for it, what can I do? What is the correct statement for it? It's not a trick question. Very straightforward. We just need to say input shape, but instead of 784, we just need to say 32 because the previous layer has 32 neurons, right? So it's going to be 32 output. Okay. We said that a network layer and the architecture of the networks is like a directed cyclic graph. And by saying that, it means it is from A to B, not the other way around. So it is directed from one direction to the other. And the other thing is there is no cycle. It means that if you go from A to B and from B to C and from C to D, you are not going to get back from D to C or B or A. No sign of cycle, right? Okay, how about this one? The topology of a network defines a hypothesis space, and that's familiar for those who participated in the quiz. And then I say that the space of possibilities is the other term for saying hypothesis space, right? And this is something that I asked you, and those who participated in the quiz, they remember this. Picking the right network is more yes, more an art than a science. Means that if we want to paraphrase it, when they want to hire, they look at the experience, because people who are skillful, they can just look at the data set and they say, for such a thing, we need to define this model, this number of hidden layers, this number of neurons, this optimizer, and so on and so forth. So only a practice can help you become a proper neural network architect. And we said that we have in our architecture, it says that loss function and optimizer, the keys to figuring the learning process. One of the things that we need to consider is for the optimizer, it determines the network will be updated based on the values that you get from the loss function, loss score for sure. And just look at this one. Imagine that we have, this is a picture that we talked several times about. Yeah. So look at the number of outputs that we have. How many outputs do we have? Awesome. So for these 10, any of these values could have one separate loss function and loss score. Optimizer is going to work with individual values or something different. The good thing is in some of the classes, one or two people at least they follow. So I repeat my question. We have loss score for 0 all the way to 9. So optimizer is going to deal with the loss score. Is it going to calculate separately for every individual loss score? Is it going to do it? Okay. I have no clue at the moment. Let's just continue this part. It says that a neural network has the multiple outputs. A neural network that has multiple outputs may have, forget about may, have multiple loss functions. So one per output. But the gradient descent process must be based on a single value. It means that the optimizer cannot use several values and it needs to be based on just one. And for multi-loss network, all losses are combined via averaging into a single scalar. So does that make sense? So technically, we are not going to deal with all loss function, all loss scores. We deal with the average of it. And remember, we talked about this part. It says that choosing the right objective function for the right problem is extremely important. And the funny example that it says, if you, for instance, consider increasing the lifespan of people and you just give that instruction to robots, they are going to eradicate all humans but 100, and they try to prolong the lifespan of those 100 people, which is not what we actually wanted. And it says all neural networks you build will be just as ruthless in lowering their loss functions. What are the loss functions that we need to know? If it's a function, if it's the data set that we can find similar data sets, we can just follow the rules and regulations that the other examples designed and defined. For instance, for binary classification, you're going to use binary cross entropy. For multi-class classification, if it is hot encoded, you are going to use categorical cross entropy. If the output is integer, you are going to use sparse cross entropy, and so on. Now we get to the keras. This is, as I promised, to finish the review in 12 to 15 minutes. Now it's the time to start a new chapter. Let me just make sure that if I actually record. Yes, it shows the recording. Awesome. So what is Keras? Is it a library? So I want you to spend 30 seconds, see what is Keras, and please get back to me. Okay. What is Keras? Yes, please. Excellent. High-level API. And TensorFlow is one of the libraries that it supports. What other libraries we can find if we search? So as James said, it allows the same code to work with several libraries, including TensorFlow. And seamlessly, it works with GPU and CPU. And it has a user-friendly API, built-in support for convolutional network. And one of the things is it's under the permissive MIT license, means that you can use for even industrial usages, or because some of the products, when they are under the open source license, you can use them for the individual purposes, but you cannot use them in the industry level. But this one, you can use it for any purpose. And it says that Keras is also a popular framework on Kaggle. Actually, still, it is the second popular after TensorFlow. And look at this one. This is something that I want you to remember. So Keras is something like an overlay on top of other libraries, like on TensorFlow, on Theano, CNTK, and so on. And if we say, it says that Keras is a model level library and providing high level building blocks for developing deep learning models. And it relies on a specialized, well optimized tensor libraries to do so, serving the back-end engine of Keras. Right? And it says that several different back-end engine can be plugged seamlessly into Keras, means that you can use at the same time for several purposes, including you can use several libraries, including TensorFlow and Theano. Anybody can tell, do we have Theano at the moment? You can search. And what do we have since 2021? What was the replacement for Theano? What is the name? Somebody said something. I heard it, if I heard it correctly. No. It starts with A. Okay, Theano was supported by Montreal University. So whenever you have a university or academia and not industrial sector, there's a chance that they do not support after a while when a project or something is done. So Acera, if I'm not wrong in pronouncing, is the reversioned of Theano. And the good thing is, if later we have different libraries that we want to add, Keras is going to welcome them too. So it says that we recommend using the TensorFlow backend as the default for most of your deep learning needs because it's the most widely adopted, scalable, and production ready. Okay, so everyone, in Keras, we define the training data. We define the type of network that we want to have, if it is sequential or functional API. And then it says that configure the learning process by choosing loss function and optimizer. And the last one is iterate on your learning on training data by calling fit. Okay. So this is just one way of defining your model. The second one, I want you to spend 30 seconds and find similarities. The first one is something that we have already worked with lots of times, like sequential. And the second one is something that we almost never used it. If you are interested, you can just go to chapter number 7 and learn about it. But spend a few seconds and see what are the similarities between these two. So if you look at this, here we have the sequential models that we have layers like this hidden layer, and the output is mentioned there. But in here, we just say input tensors. It could be any name, like A is the input shape. And the next layer is like X, which is equal to dense layer 32. And you insert the output as the last element of that line. You do the same thing for here. So you have the first layer, call it X, and you are going to just add that X at the end of this line. Based on the time that I spent on deep learning, most of the time, I can say almost all the time, I've seen just this layered format, the sequential model. And rarely, just for the sake of academia, I've seen this one. But if you're interested, you can go to chapter 7 for more information. But it says that the learning process is configured in the compilation step, and optimizer and loss functions are here. We say optimizer and loss function, and the metrics to evaluate how good we are. So no matter if you are using deep learning or shallow learning, you definitely need to find patterns between inputs and outputs. This one shows that for every iteration, in every batch, how many pictures you're gonna pick to show to neural net, and how many rounds you are gonna just go through all those. And it says that what type of network architecture work for different kinds of problem is something that you can just find out after years of experience. The last thing before the IMDb data set that we need to consider is this question: setting up a deep learning workstation. In the new version of the book, and this one, they say some of the stuff that I'm not very much, I do not feel that I agree. And I'm going to tell you why. So one of the things is it says that even for application, the speed of running an application over CPU and GPU, it makes GPU 5 to 10 times faster. For me, I experienced something 2 years ago or some 3, and I exactly timed my process. It took 30 seconds for using a GPU, and it took 30 minutes using CPU. So it means that it was like 60 times faster. This part is completely okay. Using Linux brings you less overhead and headache. And Ubuntu is just one of the options. One of the things that it mentioned is the best for deep neural nets, the best environment would be using Jupyter Notebook. Actually, it was, but now I prefer Colab because everything is already installed and the compatibility version. So all the things that we need are already installed for that. I remember just I needed to install one package. So 95%, I could say, is already there, the packages that you need. And there is one thing that apart from neural net, maybe you are interested in using your own local storage or having your own data center. There's a rule of thumb. They say if the period of time that you want to use the hardware setting is over a year, the best is to have your own data center. Means that if you want to, for a very simple example, if you want to have a 5 terabyte of data, is it better to have Dropbox or to buy your own hard drive? A very simple example. You might say that, okay, how about the failure that could happen? Actually, to me, that happened using Dropbox and the failure happened. But maintenance, the electricity amounts that you spend, so you have to do calculations. I'm saying that it's a kind of general formula. If you need to use a service over a year, the best is to have your own data center. And it talks about the GPU, the era that NVIDIA started producing. And it says that if you are serious about deep neural net, the best is to have your own GPU, guys. Not necessary. You can now use Colab. And if you go to Colab, very simple. You can just go to runtime and say, hey, I want to use GPU. It's not the best, but well, you can access GPU for free. Or you can use TensorFlow processing unit. The other alternative is using the services that we have over the cloud, like Amazon EC2, that cloud computing. C2 is for cloud computing. And yeah, it talks about the NVIDIA. And by saying that, we get to the actual part of today's session, and that is IMDb. Yes.
If I had multiple GPUs, could I like make them work together?
Well, the thing is, everything happens seamlessly. I'm not sure about how they manage it, but I know that they manage it. You can have multiple clusters and run them at the same time. And look at this one. These are the 3 tiers that we have. You see here, for instance, it said 100 GPU and 100. So these are the professional things that you can just, purchase. And classifying movies. Anybody can just search for this, telling me what is IMDb data set? Anyone? And there's one good news. This part is a fundamental part of all relevant, like NLP and any state-of-the-art deep learning topic. Just natural language processing is one of them, NLP is one of them. But the terms that we're going to learn today would be the basics for this. And apart from it, I can assure you, without having today's session, we cannot understand the code. 100% guarantee. There is 1% bonus mark for one of the questions. I just challenge you to see who can just discover correct answer. But before getting there, what is IMDb? What is IMDb dataset? Sorry? It's true, but I'm talking about, that's correct. I'm talking about the IMDb inside Keras. How many, we can just Google it, or yeah. How many samples do we have? Yep.
25,000.
Sorry?
25,000.
25,000 is a part of it, is the training part. Right? Okay, what else? 25,000 for training. How much for the testing? Sorry? Okay, so apparently we have 50%, 50%, like 25K, right? And is the output balance, means that do we have equal number of positive and negative number labels? Those who want to join the class from now, it's a good entrance because we start something totally new. The question is, are the outputs equally and evenly scattered? Means the number of positive labels is equal to number of negative.
So they are equal.
They are equal. So when the number of positive, when the number of classes, when classes are evenly scattered, what could be the best metric for us? It's not a trick question, it's a simple question. When the number of classes and the number of labels are evenly scattered, like we have 50-50 for a binary, we have 10%, 10% for numbers. What is the best metric? Guys, these are some of the questions that like machine learning 101. This is one of the questions. When the labels are actually yes, it's accuracy. So it gives me good feeling that I can just record it. So it's actually accuracy when the number of labels are evenly scattered. And if it's not, we are going to use recall or precision. So for such cases, but for this one, definitely. The other thing is, why use separate training and test dataset? Anybody can tell? Why don't we use part of the training as our testing? Yes.
So like you want to make sure that the model's not just memorizing, I guess, training data.
Lovely.
And then we use it as like this unseen data, and we want to see if it's going to be accurate with unseen data.
Excellent. Yeah. So it's not going to be the memorizing. That's one part. The other thing is, it says that it is possible that your model could end up merely memorizing a mapping between your training samples and their targets. Means that it works fine with data in hand, but it doesn't work good with unseen data. And the whole idea of having deep learning is finding a way to predict correct answers for unseen data. So a listing 3.1. Those who want to start entering the code, please enter. You can just copy and paste from there. Let me just bring it a little bit high. Okay, here. What does that num words mean here?
So that's when the maximum number of the word to check.
Good. Just remind me for yes.
That's the 10,000 most frequently.
Lovely. Yeah, exactly. The top 10,000 most frequently used words. Look at the paragraph that it explains here. It says that the argument num words equal to 10,000 means you'll only keep the top 10 most frequently occurring words in the training data. This allows you to work with vector data of manageable size. So 10,000 is quite manageable. If you see some of the words in the dictionary, you see some artist names. Even I saw that people that you never heard about their names, they were listed in that data set. But 10,000 is quite reasonable number. So everyone, please, in page number 68, we just imported IMDb. We just split it. Actually, it is already splitted. We just placed them into train data and train label, test data and test label. And we say that the top 10,000 most frequently used. And now it's the time for us to check what we have in train data 0. Guys, what do you think we are going to have there? Are we going to have reviews like the strings? Yes or no? Pardon me? It will be a string. So how about this? Just try it. Yes?
It looks like a lot of numbers.
Looks like a lot of numbers. What are those numbers then? Pardon? Yes, please. Ah. 10,000 words. Good. How about this? Let's try number 1. Let's try a few. Number 2. Let's try number 3. Guys, you see that we have a bunch of numbers, right? Something is common in all of them. What is that? Pardon me? Don't you see that they all starts with 1? Why? What I like to do is exactly asking these questions in the midterm. So ask ChatGPT and good luck. Why? All of the examples, they start with one. Are there, so do we have 10,000 movie names identical?
But the category is the same. They come under the category movie, right?
I have no clue. We are gonna just find out. I just want to plant that seed that we have all of them. Guys, how about this? Look at this one. Imagine that I have a gigantic file. I should have just write it here. I have a gigantic file like this. So lots of numbers between like this. And then I'm going to have another one here. What can you understand from this? Okay, guys, what can you understand? Huh? Lovely. Reminds me that we have some correct answers till this moment. That is the sign of beginning something, beginning of something, right? So whenever you see one flag, it shows that that's the beginning of one review. The beginning of the next review, the beginning of, these are the flags for the start. Does that make sense? What if you want to make them all the same size? Is there a way for doing that? Look, imagine that we want to have them the same size. Is it possible that they say, okay, for the rest, use 0. And for this one, I'm going to say, imagine that we have one less line and so it's going to be something like that. Guys, do you see that? So how many special characters we used so far? Till this moment? Huh? 3. Till this one's 2. One of them is for 0 padding, as we call it, and the other one is number 1, which shows that the beginning of each reading, right? At least keep it down. Okay, there is another thing. What if I don't know one of the words here? It's a name of somebody that I don't know. What should I use? Question mark. So 3 possible conditions could happen. 1, beginning of something, right? Well, if we start very much accurately, 0 padding, 0. The start of something, 1, and unknown things, 2. Does that make sense? Is there any other possibilities, Malik? I said no, just saying depends. Depends on what. No, these are all possibilities. Okay. We just tried those lines and I can't understand what is happening in here. Anybody who can explain that? James participated in. What's your name? Just make sure that you're able to work out all the. It should be someone. Pardon me?
Are you using that number for
Index of the good. Close, but a bit more. That's a good guess, actually, Stefan. Very close. How many words how many top words we are gonna consider in our dictionary? Technically 10,000, the index would be from 0 all the way to 9,999, right? Totally 10,000. I didn't understand that, but try this one. Everybody, if you just say, oh, by the way, the label of the first one, what's it? 1. What does it mean? 1 is for positive, 0 is for negative. Let me just remember this. You said number? 86, right?
Yeah.
Mean that. Look. What are these numbers? Can anybody tell? Not a trick question, and actually they are very simple. Those numbers, for instance, 1, 13, 47, 8, 30.
Index of out of like 10,000 words. So you have created a dictionary and now you are having kind of just have a one entire review section and you are just referring to that dictionary. And on the basis of that next step, you will just find it like what is the most frequent one, and what would be the review for that.
Good. You mean that this is something that many people had a struggle, so this example can help us. You remember those kind of old movies for Second World War? Some people had a kind of code book. They had numbers and they just checked that code book and said that, okay, let's decode the message. So they received some numbers, they decoded and they understood what they need to do. It's exactly like that. You say, word number 14, I go to the code book. That's the index of the word, I find it. Then word number 47. So it's just like going to the dictionary or code book that you have and check what that index means in the dictionary. Does that make sense? Huh? Okay. How about this one? Here we say maximum of maximum. Wow, maximum of maximum. Guys, what is the maximum number that you can see here? I just slow down. Here I see 4,000. That is for just the first sample. Do you see any more than 4,000? 6,000 is the winner so far. How about? Still we have something. Again, please pay attention. It should be 7 something. I'm not gonna tell the exact number. So the idea is finding that, oh, sorry, it should be number 0. My apologies. I was like, where is it? It is 7,000 some 100. If I just quickly go, my bad. You found it? Here it is, exactly. You see this? So right now, if you run this line, it's gonna give you just 9,999. But let's get rid of the first max. Look what's gonna happen. It says that for the first one, index 0, the maximum is 7,700. We just found it. For the next one, for the next one, for the next one. So you're gonna have the maximum index of each review, the word in each review. Does that make sense, Geoffrey? And then what are we gonna do? Let me just comment that. So we are gonna say, what is the maximum of the first one? You're gonna say it is what we found it. What is the maximum But instead of using that max of max, which is the best way of, we can simply use traditional form of saying for every A in the train data, means for every review in the train data, just show me the maximum of that and just do not split it by enter. Just use comma as the separator and look at the result. So it's going to just work the same way. And now it's time to get to the dictionary. We have a dictionary. Just search. Can you get any text, any help from anywhere that how the dictionary works for IMDb? Keras has some guidance. You can just get that. Pardon me? Okay. Can you just read it and see how it works? The question is, what is that IMDb get word index? What does it do? Technically, we have a dictionary. You remember that we said we have a code book that we go there and check what is the meaning of each of those indices. Done? Yes? It means that if you say, get that word indices, it's going to tell you for each word what code we could have, right? So it's going to be string, integer kind of thing, right? Key value. Is it correct? Pawan? Oh, sorry, Prakash. Is it correct? So we have words and we have the indices, right? But what if we want to switch these two? Why? Do you remember that I showed you the first review? It was like 1, 17, and some other numbers. Don't you like to see what was the original form of the review, that we just see some numbers? For doing that, you simply say, first, for every key value, like font 34,000 and so on, just swap them. Does that make sense? Means that for every key value that you have in that word index, just swap the key values and make a new value keys and make a new dictionary. By doing that, let's see what's going to happen. Look, font 34,000 is going to become 34,000 some hundreds font. We flipped them, we swapped them. Right? What else? Now, I can't understand why it says, I can't get it. Why we have get here? Why we have -3? Do you remember this? Anyone remembers what we said about the potentials that we could have? One of them was beginning. The other one was padding. The other one was unknown things. Yeah. Okay, I don't have any answer for that. So let's have a 10-minute break. You can search for that and see what is that 3. So we're going to come back at 1:10. So see you in a few minutes.
I'm gonna take care of your first. Thank you. Have a good one.
Okay, so let's continue. I asked you where that number 1 minus 3 has come from. Any answer? Is it necessarily the first few characters in? Okay. Yes.
So for me, I understand this, so this basically that we that you get all the information except the beginning, the end, that's mean 1 and 0, and we also have to avoid the questions man that's mean the work that we understand. So that's in terms of 23. So we that you get all the trees, so that's mean the minus.
Good job. Exactly. Look at this one. This is one example that I provided here. Imagine that we have that code book. You remember Second World War example? Oh, I'm sorry. The Second World War code book that I mentioned. Imagine that the now it is good. The code 0 is for I, code 1 is for M, code 2 is for A, code 3 is for student. Guys, this is just a simple dummy example, right? So what is the code? What are the codes actually in my dictionary? 0 for 1, for I, 1 for M, and so on and so forth. But look at this one. Here, I need those 3 characters, like 0 for padding, 1 for a start, and 2 for unknown. Right? So technically, Prakash, we are gonna shift all those numbers here. So we reserved 0 for padding. So it's like 0 plus 3, 1 plus 3, 2 plus 3, 3 plus 3. So these are the new indices, right? What if you want to say, okay, bring it back to what it was? Then what is the original? What is the original index for I? No, the original. Yeah, 0. So it was like whatever the index is minus 3. Does that make sense? So that is why this is the answer that one of you explained. So I say that go to the reverse word index and say get whatever I is minus 3 for every I in train data 0. Does that make sense? So in that case, it is going to just, we say that decode review. And if I see that, it's going to say something like this film was just brilliant, casting and so on. Can we understand the review? Okay, why the first character is question mark? If anyone can answer that. Why the first character is
but that's what cost 60 this year.
Sorry?
That's what doesn't is this year. So it's not my learning part.
Can you elaborate more? I can't find you. Not. Look at this one. What is the index for a start? What is the character that we said we set it aside for a start? Look at this part of the code. It says that here 0, 1, and 2 are for padding, for a start, and for the sequence. Is it correct? So the beginning would be 1, right? Okay. Just think about it, see if you can find the answer. Honestly, just give me your name. You can just give me your name. You're gonna be there. One waste your time. You can just go and do something in the coffee shop. Okay, please come. All right, okay, I'll give you the mark. Okay, thank you very much for being in the class doing something. What's your name? Yeah, your name? Sorry? Okay. And your name? Okay, you can leave. Okay, any answer for that? Look at this one. What is the number that we said we have for the beginning of the string? It was 1. If you deduct 3 from 1, what is going to happen? It's going to be -2. Do we have any? What is the first index that we have in our dictionary? 0. Do we have anything that represents -2 in the dictionary? So it's going to be unknown. But let's go to this part. I have provided you one example here. Look at this explanation. I said, let's go here to this W3 schools. And if you say try it yourself, you see that we have a bunch of things over there. And if I say go and get the model, right? It's going to show you what? What is in front of the model? This is the key, this is the value, Mustang, right? Awesome. What if I say get model 1? Do we have anything like model 1 there? And if you just say run it, uh-oh, we are in trouble. It's going to say none. What if I want to say, okay, in the case that you cannot find it, say something like 1 asterisk or 1 question mark, or how about 3 asterisks? And if I run it, it's going to be what? It's going to show you 3 stars because I couldn't find any key values over there. Does that make sense? Okay, awesome. So by saying that, as you see here, we say go to the list and try to fetch every single word, -3, and try to find, okay, by saying that now we have the reason why all the reviews, they start with question mark. Yeah. Look at this. It says that you can't fit lists of integers into a neural network. You have to turn your list into tensors, and there are 2 ways. One of the questions that I want you to think, and it has a good bonus for it, is this one. Have you ever seen those people that they write a review in Amazon? I have seen some people, they're like this. The product that you have, you see here, has these pros and these cons. And I checked it, and this is the latest review. And after 1 month, you see that another article. So, like what? So, 5,000 words. But some people, they just say, it was excellent. Good deal, done. So, what should we do for the time that some people use 5,000 words? Some people just use 2 words. Good deal, finish. What is your suggestion? How could you say this one is positive, that one is negative? Because you need, remember, all the time when you design a neural net, you should have an input size. So the input size cannot be variable like 300 for one, 2,000 for the other. So what is the solution? Yes.
Exactly. Words like, suppose I'm going with 1,000.
Okay, 1,000. So what if it is 2,000?
So basically, you are extracting the repeating words and counted. You can reduce the entire.
It is possible, but it means that feature engineering.
Whatever.
Feature engineering is not necessary. So let's not go that route. Actually, you're 100% right, but it goes back to the era that we didn't have deep learning. Okay, so think about another solution. Yes, you're saying.
Don't common blockers sometimes like graduate how much words can fit in there.
Means what?
I have a limit.
A limit means that, hey, if somebody wants to say something, they should say it in the first 200 words. Why should we bother? Right? Just let's get the first 200 words, something like that. Or get the maximum or almost above average number of words and try to just, if somebody, what if someone has just 200 words and you say, I'm going to use 500 as the input? What is your suggestion, solution for that? Guys, all of the things that we are saying, actually they implemented. We have several approaches. Yes, Nicholas.
You don't 200 word nothing with like empty data for like size, but you read more empty data.
Means 0 padding, for instance, for not mentioned values, we put zeros. Actually, that is one of the solutions. Yes. So imagine that you have 500 words as the capacity, but you're going to say the first review is 200 words. What are we going to do? You're going to 0 pad 300 zeros, actually, right? So, Nicholas, thank you. What else? That is one solution, actually. My suggestion. The paragraph that I left is here. Just read it. It's not easy to grasp, actually. One solution is what you said. So pad your list so that they all have the same length. Imagine that you're going to say 1,000. What we are going to do is turn them into a integer tensor of shape, and then use as the first layer in the network a layer capable of handling each integer tensors. If there is no value, just zero pad there. But what is the second solution?
Everything zeros or.
I have no clue, but I think that just if you read it carefully and several times, it will start telling us what is happening there. It says that one hot encode your list. That's something that we have done it before. Whether you remember it or not, for the output of numbers, that's a kind of one hot encode thing. For the zero, say 1, 0, 0, 0, 0, 0. For one, say 0, 1, 0, 0, 0, 0, 0. You remember that? So that is kind of one hot encoded. But what does it mean in here using that? Look, guys, I'm going to just tell you the gist of the things. Actually, the real job starts from now. We recorded, so let's just have it here. Imagine that we have 10,000 words, 10,000 top words. What are we going to do? We can just simply create, let me just say 0 here. And we are going to have all those zeros. And let me just bring indices for you guys. These are the zeros for the, okay, we have word index 0, we have word index 1, and all the way to the end. How many of them? Let me just have some ellipses. Tell me, what is the last index? 9999. Yes, exactly. So imagine that you find in the first sentence, you find index number 2. What are you going to do? You turn 0 to 1. You find index number 4 in the string. What are you going to do? Index this one, change the index, sorry, change the value from 0 to 1. What if you have 2 times that word? For instance, if somebody says that it was very interesting, and if somebody says that it was very, very interesting, what are you going to do? It doesn't matter. We want to see the sentiment analysis, right? If it is positive or negative. If you 10 times say it was very, 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 very good, still it is very good, right? So the sentiment analysis wants to just know that if it is positive or negative, if you repeat it 100 times, doesn't matter. Did you get the idea? So we are going to have, guys, this is the best thing that we could do. We could have the indices of the words, and we are going to search into the series of the numbers, and we are going to get to a matrix that has 10,000 columns. And how many rows does it has? Sorry? You remember 25,000 samples we had, right? 25,000. So we have 25,000 rows, 10,000 columns. Does that make sense? So every epoch goes through. James.
Yeah,
Oh, just wanted to tell you. Sorry, somebody told me 1:30. Can you imagine? No, okay. I'd love to have you more. So you see that it is 10,000 rows and 25,000 words. So each epoch is going to do what, Jason? Is it Jason? Jason, yeah, sorry. So it's going to be 25,000 samples in epoch number 1. Epoch number 2, we are going to just read you the 25,000 as well. Guys, did you get the scenario? And we are going to see if, guys, somebody has 1, 1, 1 here and 1 here. We see that they label positive, so we can guess that if some people use those combination of words, they tend to be positive. Am I right? Do you see the idea of what is happening here? So now we want to implement it. I have seen some people, their idea is just to see what machine learning and neural nets can do for them, and they just combine them with the recent technologies and invent. I've recently met with them. They are awesome people, guys. I was like, we need more people who dare to think like that. This is a fat bonus mark question. If anybody can decipher this for me. And imagine that those who do not come to the class and wants to understand this code. For the first time I remember, it took like 2 hours for me to go through all the. Oh, 2 hours because nobody told me all those prerequisites. We already have all the materials. What is the sequence? What is the dimension? Sorry? Dimension is 10,000. What does it mean? Well, actually, that's the default value for dimension. It means that we have top 10,000. So if you decide to, in some of the implementation, I remember I went through many places to see what are those things. I saw that people use 2,000, still it works fine. Means 2,000 top words. Some people exceeded that range. But here is 10,000. What is the sequence here? If anybody tells that.
Because typically in numbers, suppose if you're going with a word like that is called a sequence dictionary.
Prakash, what is sequence?
Is it not a record?
It's basically a dictionary of the words that 10,000 words.
William, you said correctly.
Right.
Yep. So look at this one. 10,000 is 10 that sorry. Sequence is that 25,000 is example 1, example 2, example 3, example 4, and so on. Does that make sense? But still, it is not easy to understand. So that is why I provided this for us. Guys, still, you want to work to get fat bonus mark, or you want me to explain? Explain it. Okay. Look at this. Explanation. Please say values equal to A, B, C. Please run that code. When you are done, please give me a signal. Done? Awesome, thank you. So after that, we say that for every count and value inside enumerate, enumerate is going to assign index to every single member of this list. Right? I repeat it. Enumerate assigns indices. So what is the index of A, Nash? Just a guess. 0, yeah. How about B? 1 and 2, right? Okay. Now, let me just show you count and value for it. It's going to show you 0 and 1. Let me ask you one thing. If I say I and I instead of count, is it going to work? So it's not sacred word, right? It could be I or anything. What about the length of value? Anybody can tell? Lovely. It's going to tell you 3. So how about this one? Anyone can tell what is the length of this one? Lovely. It's going to be 4. And imagine that I want to have 4 rows and 10 columns. Instead of 10,000 columns, let's just have a tiny, teeny sample. Look what's going to happen here. I'm going to, I'm sorry, I needed to import NumPy. I have forgotten. Okay, here I'm going to say, let's provide a length of values, which is 4, comma 10 instead of 10,000. So it's going to be 4 rows. And is it clear? Now, what if I say, show me the count and value in enumerated values? Guys, what's going to happen? It's going to show you 0, 3, 1, 7, 2, 2, 1, 3, 7. Does that make sense?
Oh,
Yeah? Yeah, because that's the new values that we assign. Are you sure? Look at this one. What were the values, William? 3727, right? Based on the length of that, we said, let's create zeros that they have 4 rows and 10 columns. Huh? And then we said, okay, now it's time to print the combination of count or I or index or whatever. And because enumerate is going to convert each of those guys into a kind of duo, that we have index and the value. Does that make sense? So it's going to be 0, 3 instead of just 3. The first one is 0, 3 count value. It's a kind of dictionary. 1, 7, 2, 2, 3, 7. Does that make sense? Okay. If I just say, please print them, it's going to be that. But let me ask you, William, what is this if I say row 0, column 3? Isn't it going to be something like this? Lovely. How about 1 and 7? So it's 4, 5, 6, 7. Isn't it going to be something like this? And the next one, 2 and 2, it's going to, I'm sorry, it's going to be something like this. And again, 7 and 3 and 7 would be something like that. Does that make sense? And instead of printing them, what I'm going to do, I'm going to say, hey, place 1 into it. Guys, is it clearer? Right? And how about my results? If you just say, remember the initial values, it was like 4 times 10, just zeros. And here we just replace those indices with 1. Getting better? Okay. So another example, and actually, Prakash, this is a real example. First sentence review. It's a kind of miniature version of the actual. How many words do we have in this? 4. So how many words do we have in here? 4. Imagine that we have 10, actually 10,000, but in this toy example, we have 10 columns. And if I say, what is the length of that? It's going to say 2. So is it possible that I say, create 0 matrices for me, which contains 2 rows, because we have 2 sentences, and 10 columns? Everybody got that? Right? Look at this one. If you say now, make indices for me like 2 and 10, what's going to happen? Huh? Okay. How about this one? If I say now, print for me the count and value thing, it's going to be, good luck. It's going to be 0, 3, 0, 7, 0, 2, 0, 7. Does that make sense? Now let's just shape it like this. We say that go to count and value in here. Guys, what is this one? 0, 3, 0, 1, 2, 3 means this guy should be 1. The next one is 0, 7 means this one should be 1. 2 and 2, this one should be 1. And again, 0, 7, we said that repetition has no role in it, right? Means that again, so let's see what is going to happen if I just say print the result. Isn't it beautiful? This is exactly what that code does. Now spend a few seconds, please. And I'm going to bring this one, this code, and in a group of 2 or 3, explain what you learned from this. I'm sorry. Here is the code, and here's the sample. Still, if anyone can explain the code with all those explanations, has bonus one, not flat bonus one, but has bonus one. I'll just spend time with your friends, talk, and spread the knowledge, your plethora of knowledge. Okay, Prakash, you wanna give it a try? Or Malik, you wanna give it a try? Or you want to give the chance to Prakash? Okay.
Basically, you're doing with it from the 25,000 sequence.
Okay, here means that
20
later we are gonna pass it to the trained data, which is going to be 25,000 rows that we have, and how many?
It's basically 10,000. Like a diamond.
Okay, so first we pass those 25,000 rows, awesome, and 10,000 columns,
Columns.
awesome. What are we gonna do in here?
Zeros, basically you have created zeros of a column of a 10,000 and 25,000 rows.
So we are gonna create a matrix that contains the length of sequences 25,000. 25,000 rows and 10,000 columns. Okay, awesome.
Next time you are using, basically you are taking the index as well as the word.
Index and
Word basically that is an index again of suppose because when we are using the data set, we are getting the indexes.
lovely. So look at this one. For every sequence that we have in enumerate of these sequences, means that for every single word that we have, right? We are gonna get the index of that.
Yeah.
Now what are we gonna do with this?
Basically, then we will find a row and the columns.
So the row is there already. So it's gonna be I, right? Okay, so what are we gonna do?
Basically, if we will find that position in our whatever we have data we got it. So on the basis of that, we have a zeros, a matrix of zeros. We will just modify that matrix of from 0 to 1.
Awesome. So can we say, to ease the job for us, we could say it's better to say I and row in rows, in enumerated rows. So what we do actually, we are gonna say, what do we have here? If it is row number and that sequence, change it from 0 to,
0 to 999.
well, no. The sequence is from 0 to, we change the value of that place from 0 into 1.
Yeah.
So if it is 0, remember, we have tons of zeros, and we are gonna find the equivalent index and we convert them to
What?
1. That's it. And repetition has no role. As you saw that here, we said very, very 2 sevens, but still the value just shows 1. Huh? Okay, now we understand this code. We are gonna run it. And we say, show me the length of the train. It's 25,000. Length of the test, the same way. Here we apply what? The train, we apply that vectorization into the train data. Remember, intentionally, I provided that for index 0. Look, here the train data has, if I go all the way to the left, we have 1, we have 14. If we go further, we have 4. Guys, do we have 2? We have 2. Do we have 4 again? We have 4. Do we have 2? Yes. And if you search, you can see that we have 3. Why I'm saying that? Because after changing those values, look what's going to happen. Now it's the time to say, show me the X train. It's going to be a bunch of zeros and ones. Does that make sense? It's going to be a bunch of zeros and ones. So for index number 1, we had something, check it. For index number 2, we had something, so check, and so on. Instead of saying that, you could say X train, row number 0, all the columns. It's going to be 10,000 as well. And if you say that, what is the shape of that? It's going to say the X train, 25,000 rows and 10,000 columns. Lovely. And how about this one? 25,000 rows. And then these are for our labels. Labels could be either 0 or 1, means positive or negative. Didn't we say deep learning is happier to work with float numbers between 0 to 1? So for doing that, we just simply say convert the type to float 32. Does that make sense? Okay. And the thing that you see here, we say explanation numpy dot array. Okay, let me just show you this. If you say, show me what do we have here, it shows you kind of a scalar 0 in that. And if you say, show me the value in there, it's going to say it is 0 dot, which is not the same as this one, and it is a floating number. Does that make sense? By saying that, we finished that part of the discussion, and we get to this place. And yeah, it is pretty much in this part. So before we continue, because it is now 1:50, let me tell you, overall, we need something like 15 to 20 minutes to make 2 sections align with each other. Do you want to have 10 minutes break, or you want to continue and finish it sooner? Continue? Okay. So look at this one. Here, the building block of, you might ask that, hey, Reza, why the other groups, they took a while? Because they spent something like 15 minutes on the question that they asked, and some people got 1% even, but no interest in this group. So building your network, it says that the input data is vectors. And the labels are scalar, like 1 and 0. This is the most desirable format that you could imagine and you could want. Everything is number. perfect, no string, because remember, what you deal with is already converted version of the review to some integers. You just need to do encoding to hot encoded format. So left side numbers, right side numbers. And it says that this is the easiest setup you'll ever encounter. A type of network that performs well on such a problem is simple stack of fully connected or densely connected layers. And the activation, we are going to talk about it next week thoroughly. What is the activation that we are going to use? Really for the hidden layers. But for the last one, what are we going to use? Why softmax?
Sometimes the one that goes either to 1 or 0.
Please explain more. I'm listening.
Graph, graph,
Uh-huh.
and essentially like you're taking middle, you put either the lower up to 1. or
Awesome.
to 0.
Excellent. I'm gonna just repeat what you said in a few seconds. Look at here. It says that a hidden unit is a dimension in the representation, the space of the layer. We know that, but here, one of the things that it mentioned is having more hidden units. Guys, if you are dealing with a complex problem, like something that not easily to solve with a shallow learning, you can add number. You remember in the previous semester, we had one part that I said, go and play around with those examples. There were neural networks that you can add number of hidden layers. You could add neurons into it, and it could just solve the complex problems. The thing is, if you add more hidden layers, it says that having more hidden units, a higher dimensional representation space, allows your network to learn more complex representations, but it makes the network more computationally expensive, and that's the problem. It may lead to learning unwanted patterns, mean that you just specialize your network, you make it work perfect with data in hand, but not unseen data. This is the definition of overfitting. This is a question that we had in the test, in the quiz. We said how many layers to use, how many hidden units to choose for each layer. You remember the sentence that said it's more an art than science? It's exactly something that happens based on experience. I want you to read this paragraph. I'm gonna give you 30 seconds, please read it yourself. And tell me what is the gist of it. Okay, how many hidden layers do we have? 2 hidden layers. How many units in each hidden layer? Okay, the parameters that you can change. The parameters that you can change, like the number of hidden layers, the number of units in each layer, the number of epochs, for example, the batch size, and so on. What do we call those parameters? Something parameters. Yes, you're close. Sorry? Awesome, Rachel. Rachel, just for my curiosity, you spend time in reading a book? Okay. Even that one shows. That's some. Good job. Let's look at the next part. The next part says a ReLU is a function meant to zero out negative values. So you know that it's going to get rid of the noise, for instance, or it's going to bring non-linearity. And we are going to talk about it next week. It's actually in the highlighted part. It's in a creamy color before the conclusion of the chapter. And the other thing is, it says that a sigmoid squashes arbitrary values into the 0 and 1. What does it mean? It squashes the values into 0 and 1. That's what you said. Yes, please.
It's a threshold.
Uh-huh.
It's higher than the threshold of 1. So then.
Awesome, William. William, you made 1% today. Good. And there is no absolute positive or absolute negative. So it's not possible to say that one sentence is 100% positive. What sigmoid does is, if it is 5, 0.5, or a little bit higher, it's going to consider it as positive. It is more about probability distribution. And if it is less than 5, 0.5, it's going to bring it to the category of 0 or negative. Does that make sense? So for the last layer, you don't want to hear that, you know what, this review is 20% positive, 80% negative. You just want to know if it is positive or negative. And this one shows the architecture of the network that we defined. We say that let's have 2 hidden layers, 16 units, 16 units. And what is the output? Just 1 unit to say if it is 0 or 1. This is what we are gonna create. And next week, we are gonna just work on this one. So it says that from Keras imports models and layers, and we are gonna say 216 units in our 2 hidden layers. The first layer should contain 10,000 inputs. And then the last layer, which is going to have 1, has sigmoid as the activation. I told you about this creamy part. This is what we are going to talk next week. I'm going to stop recording. If there's any question that maybe others could benefit from, please let me know. Other than that, the things that we spent almost 10-15 minutes in the other class while I'm taking care of the attendance is, please just open assignment number 2, start reading it, see which parts are already known, which parts are not clear, and talk to your friends, see what you can do. Any question? Assignment number 2. Yeah. You already have all the assignments in the folder on the left side of the panel in the course content. Yeah. So I'm going to just stop recording. Thank you.